Hey everybody, in this video we are going to be multiplying complex numbers. When it comes to multiplying complex numbers, you do have a little bit more to remember than with adding and subtracting. I is going to replace anytime you have a square root of -1. So the I is the part that is allowed to stay in the answer, but I must be written to the first power and I cannot be in a denominator. What obstacle will we run into when we're multiplying? You're probably going to see something like I squared or something like that pop up. I squared, actually, let's not put that in red. Red is what could stay in the answer. I squared, we can swap out with -1. So that might pop up. Is it possible to see I to the third or I to the fourth? I guess, but you're not really going to see it here. So we'll reiterate the rules that have to do with I to the third and I to the fourth and so on in a different example. So for right now, the two things that you really want to remember are involving that I is allowed in your answer as long as it's in a numerator into the first power. In that case, I squared would be swapped out with -1, and those are the ones that you will deal with the most. So let's go ahead and get into this example. I guess we could do this color. Okay, so if I want to multiply a binomial times another binomial, we're going to use what we might refer to as FOIL. Basically, we are going to distribute the 2 to both things, and then we're going to distribute the -3i to both things, and we'll have 4 pieces, and we'll kind of clean it up, combine like terms, yada yada. First, outer, inner, last. That's, we know what that is. First times first, I have 6 outer, I have 8i inner. Now I have -9i. I'm actually going to write it underneath. You guys know I like to stack things vertical, so it makes combining like terms easier. Now last times last is -12i squared. Since I know that I squared is -1, my -12i squared will become plus 12, and I'm going to write it right there. I'm going to combine like terms, and I will have 18 minus 1i. Obviously, writing that 1 isn't totally necessary, and that is our final answer for that one right there. Done. Next one up. Please, if you want to be respected in the world of math students, you will not just square each item inside this parenthesis. You should know better than that. When you square a binomial, you cannot. When it's all a product, if that plus or minus signs were not in there, you could go ahead and square everything you want inside. Great. But when you have a sum or difference, immediately you have to write it twice. It's so nice, we write it twice. So if you could do this step in your head, beautiful. If you cannot, be honest with yourself and please write it twice. And then we repeat the process. First times first is 16. Outer is plus 12i, and so is the inner. The inner is also 12i. You should get the same thing for outer and inner if you're multiplying something by itself, right? And then last times last becomes plus 9i squared. And similar to what we mentioned before, I squared is equal to -1. -1 times 9 is -9. So instead of this, I'm going to go here. I'm going to write -9, and I'm going to combine the like terms. 16 take away 9. I have 7 plus 24. That's 4. Hello. What kind of 4 is that? 24. I was combining with the I, and that's it. All right. So 7 plus 24i is the final answer. And there you go. So far, so good. I hope so. Last example. Let's get the little hedgehog. Hang on the corner, guy. Thank you much. This case is a special case, and this one's going to come in handy. You're going to see situations like this. These, actually, let's brighten up the color. Let's do something else. Make it stand out. These are, what are these called to each other? How are they related? They are called conjugates. Give things names. Conjugates, you keep the beginning, you change the ending. When do conjugates come in handy? Some of you might remember conjugates came in handy when you had a denominator like 3 plus root 2. We would multiply on top and bottom by 3 minus root 2, and it helped us get rid of our radical. And we also have been foreshadowing I is not allowed in the denominator because I is low-key a radical as well. So we want to make sure we keep these little things in mind because they're going to come in handy. So if that got rid of the radical, it's probably going to get rid of the I as well. Okay, so keep that in mind. Let's multiply these just like the last two examples. First times first, 6 times 6, we have 36. Outer minus 30i. Inner plus 30i. Look at that. And then last times last is minus 25i squared. But what did we say? I squared is negative 1. So minus 25i squared is minus 25 times negative 1 becomes plus 25, stacking it so I can combine like terms a little easier. These two cancel out. Negative 30 and positive 30, both with an I, is 0i, which is 0. And then 36 plus 20, 36, 46, 56 plus 5 more is 61 and done. So did it get rid of the I totally? It sure did, right? We have no I, it's 61. Excelente, right? So keep that in mind because when we have to rationalize denominators later, that's probably going to come in handy. Okay, so that's the end of these examples. I hope that you understand the multiplication process and the usefulness of switching out I squared for negative 1 on the SAT. They do mention like, oh, don't forget I squared and negative 1. That doesn't mean you should be plugging in square root of negative 1 into your work, which a lot of people think you have to do because they mention it. No, they're just reminding you what I is and where it comes from in case I squared comes up really. So don't be a fool, just think smarter, not harder. If you get it, got it, give the video a thumbs up. If not, thumbs down. Give any questions, comments in the comments section, and check out the playlist at the end screen right now. And maybe you could find more of what you're looking for. That's it for now. Adios.